Hello, Math 1. This lesson is on 9.7, so make sure you take notes here. These are basically solving using elimination, but with the end result being a special case. So, looking at this, we know when both equations are in standard form, the best method to use is elimination. So right here, when I look at example 1, I notice when I add the x's, I don't get 0. When I add the y's, I don't get 0. But I know I could easily change this 2x into a 4x by multiplying by multiplying this entire equation by 2. Because now 2 times 2x is 4x. 2 times negative 5 is minus 10y. Equals 2 times 6 is 12. And if I write the other equation underneath it, now I can go ahead and add these vertically. I notice 4x minus 4x eliminates the x's. So you get 0x. But also, what happens here is when I add the y's, they cancel out also. So 0x plus 0y equals 11. So you basically end up with 0 equals 11. If you solve the system and you eliminate both variables, so you eliminate both variables, number 1, and number 2, you end up with a false statement at the end. What that tells you is there is no solution to this system. And as we said at the beginning of the chapter, if a system has no solutions, what does that tell us about the lines? The lines would not intersect, meaning they are parallel. So that would tell us the lines are parallel. Okay? So, one solution scenario is no solution. Now the next one, right away, if I look at this, if I add the x's, they don't eliminate. But when I add the y's, they actually eliminate right away. So here, if I add everything vertically, x plus x is 2x. Y minus y, those eliminate. So 2x equals 7 plus 3, which is 10. Now here, when I used elimination, only one variable eliminated. It actually leaves me with x to solve for. So I would divide by 2 to get x, so x would equal 5. Now I can plug that value back in to one of the original equations. So 5 plus y equals 7. What plus 5 gives you 7? Well, if I subtract 5, y would equal 2. So this here would have one solution. Okay? Now, if a system has one solution, you know right away that those lines would intersect. So here, I would have like this line here. Then I would have the other line like this, and that intersection point would be at the solution, which is 5, 2. So the second possibility is to get one solution. Now the last one, if I look at this last problem, right, the first equation is written in standard form. But the second equation, I'd have to move the 3y over. How do I get rid of it? Well, I would go ahead and subtract 3y, but when I line it up under the first equation, I want to write the x term first. That's positive 2x. Since it's negative 3y, I'm going to subtract 3y equals 4. Now I look. If I add my x's, I don't get 0. If I add the y's, I don't get 0. But I know right away if I multiply 2 by 3, I can eliminate the x's, right, by turning the 2x into a negative 6x. So I'm going to multiply the second equation by negative 3. My first equation stays the same. 6x minus 9y equals 12. The second one would become negative 6x plus 9y equals negative 12. Well, what happens here? Well, 6x minus 6x gives me 0x, plus negative 9y plus 9y gives me 0y, equals 12 minus 12, which is 0. Here, 0 equals 0. So right there, both of my variables eliminated. I have no variable to solve for. So no variable to solve for. I end up with a true statement at the end. I get 0 equals 0, or a number equals the same number. It could happen either way. Anytime this happens, I know it's the same line, and my answer would be an infinite number of solutions. All right. So anytime you get 0 equals 0, you know you get infinite number of solutions. Now, what would that graph look like? Well, think about it. If they're the same line, I'd have one line and then the other one would be directly on top of it. So it ends up being a graph of just one line. Now, these special cases, no solution and infinitely many solutions, do these happen a lot? No. I would say maybe 5% at a time. So don't think that there's going to be a lot of those type of problems. Now, the first one on the next page, right? What we're trying to do now is decide what is the most efficient method to solve a system. So remember, we have two methods. One, we have substitution. We want to use this if a variable is easy to isolate. Okay, so we want to work smarter, not harder here. So if we can either get y equals or x equals an expression, I know I can use substitution. If not, elimination is going to be your best bet. And with elimination, you want to be in standard form, right? And if both of them are in standard form, then you can go ahead and use elimination. So the first example here, if I look, notice how I have x equals. Right there, this bottom equation tells me that substitution is the best method to use. So I would go right to my t-chart. Negative 2x minus 7y equals 3. Then x equals negative 3y minus 2. Now I know I'm going to take this value of x, and anywhere I see an x in the other equation, I'm going to replace it with that value. So I'm taking the negative 3y minus 2 and I'm plugging it in. So negative 2, I'm going to kick out the x and replace it with negative 3y minus 2. I have to bring down the minus 7y equals 3. Now I know I can take and solve this equation for y. So distribute 6y plus 4 minus 7y equals 3. 6y minus 7y is negative 1y, plus 4 equals 3. Subtract 4, negative 1y equals negative 1. Y is equal to 1. Once I know the value of y, x is equal to negative 3 times 1 minus 2. That would give me negative 3 minus 2, which is negative 5. Here, I do have a solution, and that solution would be the ordered paired negative 5, 1. Now, when I look at the next example, okay, both of these, if I look, the x's are aligned vertically, the y's are aligned vertically. I know elimination is the best method to use here. But here's the thing. If I add the x's, I don't get 0. If I add the y's, I don't get 0. I cannot multiply 2 to get 3, 2 by anything to get 3. I can't multiply anything by 3 to get 2. Can't multiply anything by 4 to get 5, and vice versa, right? So what do I have to do? I'm going to try to look here to see what variable I can force elimination by multiplying one or both equations. Now I know if I can turn 2x into 6x by multiplying the top equation by 3. I also know I can take the bottom equation and turn the 3x into a negative 6x by multiplying everything in the bottom equation by negative 2. So right away here, right, 3 times 2x would be 6x. 3 times 4y would be plus 12y equals 3 times negative 8 is negative 24. Next, negative 2 times 3x is negative 6x. Negative 2 times negative 5y is plus 10y equals negative 2 times negative 1 is 2. Now, if I look, the x's add up to 0, they eliminate. Now, 12y plus 10y is 22y equals negative 22. I can divide by 22, and negative 22 divided by 22 is negative 1. Now I go back to one of the original equations, say 2x plus 4y equals negative 8. So basically I took this equation, brought it over here. Now everywhere I see a y, I'm going to replace it with negative 1. So 2x plus 4 times negative 1 equals negative 8. 4 times negative 1 is negative 4, so 2x minus 4 equals negative 8. I'm going to add 4. 2x equals negative 4. Now I can divide by 2, and x equals negative 2. So our ordered pair solution here would be negative 2, negative 1. So this gives you an idea of when to use substitution and when to use elimination. There is a time for each one, right? Just to give you an example, number 3, because both of them are in standard form, you could use elimination, or you could solve for y in the second equation and use substitution. If I look at example 4, I know I'd want to bring the 3y over, right? Put it in standard form and use elimination. Okay? So what I want you to do is you guys are going to work on example 3 and example 4 and then work on homework.